Hello, everyone, and welcome to a new episode of the Routing Loop. I'm Alex, for those of you who don't know me already, although I've been around for quite some time, together with the Routing Loop team, Tom and Matt and Jamie and Sid. For those of you who don't know who we are and what we're doing here, the Routing Loop is a live stream where we talk about all AWS networking and content delivery services, also network monitoring and observability, which is our topic for today. We are live every Wednesday, starting 11 a.m. Pacific, 2 a.m. Eastern, 7 p.m. UK time. Yes, I got the time zones right. That's great. So thank you all for joining us today. I see already a bunch of folks who've joined us who are longstanding viewers of this show. I think we can call you folks already part of the team. So thanks for joining us, and let us know in the chat where you're joining us from. I'm today in very sunny and warm Seattle, which is a very big surprise for me. I admit I've never been into Seattle in summer, but it's amazing. It's so warm. I'm originally from living in San Francisco, so San Francisco is super foggy and windy during summer. I see folks from LA. Welcome, welcome. How is the weather in LA? How is the weather in Netherlands? It's summer still, so it should be warm. And from San Francisco, and it's actually sunny today. Well, that is my luck. I have to tell you, folks, that every time I leave San Francisco gets sunny. I don't know why. I have to figure that out. But yeah, thank you for joining us. We see folks from Austria. Thank you for the feedback. Really excited to be here with you folks and talk about network monitoring and observability today. Now, this is our third episode in the series of network monitoring and observability. And Vishwas here is already a longstanding partner of ours and guest on the show. It's your second time on the show, Vishwas, right? In this series, you were actually in the first episode 2 weeks ago talking about network monitoring and observability overall. So before we dive right into the topic of today and do a bit of background on what are these tools and what they're helping you folks, all our customers, use. Vishwas, do you want to go ahead and introduce yourself for everyone who hasn't seen the first episode in the series?
Yeah, absolutely. Thanks, Alex. Hey all. Thanks for making the time. My name is Vishwas. I'm a product manager at AWS. I did the first edition of Network Observability series, and we couldn't cover a lot of things, and I did want to cover a lot of things. So Alex was kind enough to let me onto the show again, which feels good because looks like everybody's happy with what I had to say in the first series, and looks like there were positive feedback. So happy to be here. But this time we are going to go deeper into one of the services, right? So because last time it was all just slides and stuff. So this time we're going to actually do some hands-on stuff. Yep.
Perfect. And because we keep talking about last time, if you folks are interested in looking at the previous episodes, you will find them on our website, theroutingloop.net. And hopefully that's going to appear in the chat really soon as a link for you folks to follow. Oh, perfect. I see Erie edits here is it's right on point. Thank you. Thank you so much for the help here. Yes, go to our website. You will see there in the top right corner a previous episodes tab, and you get all the recordings there. We post them on our YouTube channel. And today we're live on Twitch and YouTube. We usually are. So for those of you folks who are not yet following us on YouTube, go ahead and do that. You'll find all the previous episodes there. Now, as you were mentioning, Vishwas, in our first episode in the series, we talked a bit about CloudWatch network monitoring and observability tools, and sort of the tools under our toolbox in order to achieve a comprehensive network monitoring strategy. Last week, I had Victor on the show, and we talked about VPC flow logs and network firewall logs and how you can use some AI-assisted queries and insights to get more information from those flow logs that you would be capturing. And today we have a demo for Network Flow Monitor. So let's get right onto it, Vishwas.
Yes, happy to. Yeah, Victor's call should have been interesting too. Yeah, there's a lot of things over there. So hopefully the audience got a ton of good information from that session. Okay, so
Awesome.
um, yeah, diving right into it. Um, Let me actually, before we dive into the demo, for
Mhm.
the audience who were part of the first session a couple of weeks ago, and for audience who are new to this session, what I want to do is just take 5 minutes to go over Network Flow Monitor again, just to
Perfect.
put context, and then we can go and then it will all be just on the console, right? We won't look at the slides or any of that stuff. So okay, so we discussed 2 weeks back what Network Flow Monitor is. Just a recap: Network Flow Monitor is our passive monitoring.
Vishwas, sorry, just two things before you start. Please go into the presentation mode because that's going to make it a bit bigger for all of us here to see. This is perfect. And second, please put the mic a bit closer to your. Okay, that's perfect. I think
Let's see.
that should be fine.
Is
Okay.
this better?
Yes, much better.
Okay. Okay, cool. Thanks, Alex. Yes. So, Network Flow Monitor is one of the services under CloudWatch Network Monitoring. The other two we discussed were Internet Monitor and Network Synthetic Monitor. Now, the today we're going to spend all our time on Network Flow Monitor. And so this is our latest service that we launched at reInvent last year. And Network Flow Monitor, as the name says, is about the network flows, right? This is not related to VPC flow logs or anything. This is essentially, we do look at the four tuple information, and then we went metrics for those flow tuple information, and also the network performance. But so in this case, we actually, it's a passive monitoring technique, right? In the sense that we actually look at your workloads to come up with performance metrics. Unlike in the network synthetic monitor case, where you have active monitoring, you send out probes and then you measure the packet loss and latency. Here, we are looking at your actual workloads. And so in order to do that, we have something called as a network flow monitor agent, which is an open sourced agent that you can install on your compute instances, EC2 hosts, and EKS nodes. And what the agent does is, yeah, go ahead, Alex. You had a question.
Just super quick. You said we have an agent, and you said that agent is open source, right?
Yes.
Oh, that's
Yes.
perfect. Can
Yes.
we get the link into the chat for the agent? It's actually the code is on GitHub. So you folks feel free to go there and have a look at it. It is eBPF based, right? So it's super optimized for not taking a lot of memory and CPU cycles from the workloads from actually the EC2 instances, right?
That is correct. Yes. So we took a lot of care in making sure that the agent is highly optimized for CPU and memory. And we do around 500 flows with less than 1% CPU and around 50
That's
MB
awesome.
of RAM. Um, so yeah, and we put all the security guardrails around it, so it doesn't go over a certain amount of memory and CPU cycles. So all of that is taken care of. Yes, it is an eBPF agent. It has essentially two components to it: one that runs on the kernel side, and one that runs and a component that runs on the user side.
Mhm.
So we don't inspect any traffic or anything. The eBPF agent essentially subscribes to the kernel notifications for TCP traffic, right? For example, whenever a handshake happens, or a retransmission event happens, or a retransmission timeout, when a bytes gets sent or received, and thereby giving us metrics for the TCP flows, which gives us an indication of what is the state of the TCP traffic on that particular host. Right. So this is how we can figure
Excellent.
out what is the network performance that a workload on that particular EC2 instance or EKS node is receiving from the underlying network.
That's awesome. Okay, so this is great because one of the things that I usually get asked is network flow monitor. Okay, so I have to collect flow logs. The answer is no,
Yes.
nothing to do with flow logs. Flows in networking are essentially those five tuples of IP source, IP destination, port destination, and protocol. So keep that in mind. Nothing to do with flow logs. Actually, these are two complementary
Complement.
monitoring and observability solutions, right?
Yes. So actually that's a very good point, Alex. What you brought up, the crux of Network Flow Monitor is that we want to give customers end-to-end visibility of the workload metrics plus the state of the AWS network, right? And if you don't have this, what you typically will have to do is you'll have to go and collect VPC flow logs at all the different points in that path, and then stitch all of that information together, do all that analysis together. That's one. And VPC flow logs does not provide you any performance related metrics. It only provides you the data transfer plus accept reject kind of things. So those are the two fundamental differences between Network Flow Monitor and VPC flow logs. And the idea here is customers shouldn't be going and do all of that work themselves. We do this from an end-to-end perspective, and then we present that to you as a customer, so you can then use that information to to build on top of it.
Awesome. Okay, love it. By the way, for those of you who keep joining, I see here the numbers of folks who are joining the live stream increasing. Um, One note first, we're talking about Network Flow Monitor. We're going to dive right into a demo in about 5-ish minutes. And Vishwas here is going to lead us through that. Please, if you have questions, put them in the chat. We're here to answer your questions. This is one of my favorite session types because it's super, super interactive. So if you have questions, feel free to drop them in the chat and we'll answer any and all of them to the best of our abilities. Thank you, Vishwas. Go for it.
Cool. Yes. So that's the metrics piece. So what you see in this slide about this particular line is what you as a customer can control, which is the agent's deployment of the agent on your host and all of that stuff. And then whatever you see below this line is essentially the magic that happens behind the scenes, right? So what we do is from the agent, we get the file tuple information. Then every 30 seconds we aggregate it in different dimensions, and that gives us a view into the workload performance from your perspective, from a customer's perspective. And then what we do behind the scenes is we essentially build the path for those flows, right? Very at a very high level, what we do is we take a snapshot of your account or accounts, because we do support the multi-account scenarios. For example, let's say you have an EC2 instance and you're talking to S3 on the other side, or you're talking to an EKS on a different VPC in a different region, or in a different AZ. What we do is now we need to understand what these destination or remote IPs are, right? Because a flow will only tell you the file tuple, it will tell you the destination IP, but it doesn't tell you where it is. And without understanding the topology, it doesn't make any sense. That IP could be a private IP, it could be a public IP, it could be in the same region, a different region, it could be a partner IP, it could be so many different things. So what we do is we take a snapshot of all the accounts where you onboarded for Network Flow Monitor, and then we construct that path. So that's step number two. Step number three is that based on the end-to-end metrics, we figure out a baseline. We say, okay, this is kind of an average latency that you have for this particular workload over a period of time. And whenever that baseline gets broken, meaning there's an anomaly, let's say there is an increased packet loss and increased latency, we then go look in that path that we have constructed to see whether at an overlay or an underlay perspective, if there is a network event that is correlating with that anomaly that you're experiencing. And if we find strong signal, which we are confident about, then we vend all these metrics through CloudWatch. Right? That is basically what's happening from an end-to-end perspective in Network Flow Monitor.
Interesting. So let me see if I got this right, because I'm sure everyone here is trying to sort of create a mental picture of this. Workloads running on AWS, let's say my EC2 instances, my EKS clusters run in my VPC. These are running in the what you called overlay, correct? It's like my view, my customer sort of pieces, nuts and bolts of interaction with the infrastructure. Cool. From the AWS perspective, there's also an underlay, right? All the network infrastructure that powers the overlay, and that's from a shared responsibility model. That's AWS's problem to deal with, right? So this is really awesome, because right now, if I got this right, using Network Flow Monitor, you no longer have to look at AWS as, oh, it's this black box that I don't get and I don't have any visibility in what's happening under the hood. these metrics actually tell you when there's significant information around, okay, there's something affecting this workload or this flow specifically from this EC2 instance to this other EC2 instance or this EKS cluster, right?
Yes.
That's
Yes. So
great.
customers always tell us, right? Like, hey, I migrated all my workloads from on premises to AWS. I used to have a lot of visibility before. Now I lost some of it. Can you give me more insights? Especially when there are, eh, even when customers don't know if it's an AWS network issue, they see some impairments on their workload and they want to know, is this something that they need to chase or AWS is actually taking care of it, right? And so answering just that question solves a lot of pain points for our customers, and so based on that, we kind of we work backwards from that, like how do we give a very strong signal to customers, and so then they can prioritize their efforts based on that information. Now the cool thing about this, Alex, is that the same actually a lot more information about this event is actually being fed to our internal support teams and service owners, right? So
Oh, that's really cool.
right. So a lot of the customers here are my customers externally, but I also have internal customers who look at this information and say, "Oh, Mr. X is being or this customer is being impacted on this certain path, and this is the reason." So now you can see how that the time that it used to take for meantime to detection and remediation is considerably shortened because we don't have to go to customers and ask, "Hey, can you please recreate this or give us more information about this event," and so on and so forth, because we have that view in the back end as well.
Awesome. Okay, so not just Alex as an AWS customer gets to see this information, but you can vend all of this information to, for example, AWS managed services that are building on top of the infrastructure as well and providing services to Alex at the end of the day. This is great. This is awesome. And I think back to one of the things that you mentioned at the beginning, because I think it's a really important one. You said it's really easy right now to say, okay, is it a me problem or is it an AWS problem? I think that's probably the most important piece because if I know that it's a me problem, I can go see, oh, did I do a deployment yesterday? Did I do a code upgrade? Did I do something based on my app monitoring and pipelines and sort of code deployments and so on that might have impaired the my application, or it's something on AWS side, and I don't necessarily have to do anything if it's on the AWS side because like AWS should take care of it, and I'm just opening a support case. AWS probably already knows about that because it's giving me the signals, so these support teams are probably already on it, and I'm just saying, okay, this is the problem I'm seeing. This tool is telling me it's on the AWS side. These are the metrics that I'm receiving. You go fix it.
Yep. And on top of it, customers can build on top of these signals, right? Like the network health indicator is the one that tells us if it's an AWS issue or not. And so if it is an AWS network issue, while AWS is taking care of it, customers can use that signal to do an easy move, shift over, or move a certain workload from a certain resource to something else, things of that nature. So there are remediatory actions that you can take as a customer based on these
Mhm.
signals, right? So
Awesome. Yeah, that's great, folks who are joining us. All of you here in the chat, and those of you who haven't written yet on the chat, please let us know if you have any questions. We'd love to hear more from you.
okay, so I think now let's jump into the demo.
Yes, absolutely. Let's do it. I can't wait. I have to admit that I have not yet set Network Flow Monitor in my account. So I haven't yet played with it. So I was looking really, really forward to this session so that I can learn how to do it. I'm sure it's pretty easy. I think we also have a blog about how to set all of this up. I've seen it. Definitely, we can put it in the chat. But yes, I was lazy, Alex, and I didn't set it up yet. So walk us through it, Vishwas.
Okay, sounds good. So what I'm sharing here is the new customer experience, right? The onboarding experience. So this is a CloudWatch service. So if you come to yeah,
Vishwas, one thing, please
go ahead.
do Command plus, zoom in
Oh,
a bit because it's
oh yeah,
pretty
okay.
small.
Think.
Okay, perfect.
Okay, cool. I hope this is better. Okay,
Mhm.
so if you to access Network Flow Monitor, you need to come to the CloudWatch console, and under CloudWatch console, there is all the different metrics, logs, APM, all those. And then under network monitoring, this is where all the three services that I mentioned previously exist: synthetic monitors, internet monitor, and flow monitor. So if you click on flow monitor, you come to this landing page. And if you're a new customer who hasn't onboarded to network flow monitor, there is a small video that talks about the value the product brings, which is essentially what we just talked about.
Cool.
And then some of the use cases, and you can there is also the sample scenario that you can try out, and all this good stuff. Now, uh, and then the first step you need to do is you need to initialize the network flow monitor. Click on that button. So in this case, by the way, this is where the experience can differ based on whether you are part of an AWS organization or it's a single account. So in this case, I'm part of a AWS organization and I have the management account. So let's say, and this is important, right? So in a single account scenario, um, your EC2 instance could be in the same account. Let's say simple scenario is EC2 to EC2 flows. So, and both of these EC2 instances are in the same account, and so you can just onboard to the single account, and then you should have complete visibility. But if the flows are going to an EC2 instance in a different account, or traversing a TGW, which is in a shared VPC, or an NLB, which is in a different account, then you need to go towards the multi-account setup. And in the multi-account setup, essentially, if you're a management account, then you can just add. We use the trusted access methodology, so you can go and add different, delegated admins into this account. And if you're a member account, you'll just have that account, so you don't have to worry about delegated admin and so
Cool.
on and so forth. And so, yeah.
So that means that if I'm just a member account in my organization, I can see all the things in my account, right? And
Yes.
if my organization has onboarded to this at an organization wide level, there will be a management account or multiple management accounts. I can have more than one.
Right now, we support one management account,
Mhm.
and
Okay.
then no, you can have multiple management accounts. Yes. Now you can have one delegated admin under
Okay.
that management account, and that delegated admin can add up to 100 member accounts, right? So
Okay.
that
Got
means
it.
if the flow is going through any AWS construct, which is in any of those 100 accounts, then you have visibility to that.
Got it. Got it. Okay. Awesome. Okay. Then,
Right?
and just to clarify for everyone, accounts are an AWS construct that help you separate billing and resource deployments and IAM access permission. So they're this logical boundary that help you separate or uh, add a boundary around these constructs for billing purposes, quota management, IAM permissions, security, and so on. So multi-account deployments are a best practice. Don't put all the things that you have in a single account and single VPC because it will be harder for you to scale. So this is great. It's awesome that it's integrating with organizations and it supports multi-account. Love it.
Yes. So just on the multi-account setup, if you come to the on the CloudWatch console, if you come to settings, this is where you set up the multi-account or the
Mm.
organization support. So we are integrated with the CloudWatch org support as well. So AWS,
Oh,
I
that's
mean,
awesome.
CloudWatch released organization integration earlier this year, and so we are building on top of it. So if you come here, you go to organization tab. Here, you can set up the organization and you can register a delegated admin. For example, I'm the management account, so I can, let's say I want to get somebody to be a delegated admin. I can go here, enter that member account as a delegated admin, and enable trusted access, right? So that means, so let's say if there is a networking account in your organization, then that networking account becomes the delegated admin, and we give the trusted access to that delegated admin. And then the delegated admin essentially can go and add member accounts up to 100 under that organization, right? So the idea here is, since network flow monitor is for the networking persona, you probably control all the resources such as TGWs, VPCs, and so on and so forth. So you become the delegated admin, and then you can set up the member accounts. You can pick and choose the 100 accounts and set it up. So once that is set up, the we then go to the next step, which is deploying the agents themselves.
Awesome. Let's see that. So I've selected the accounts. I've done the orgs integration if I have that. If not, I'm just using it in my local account. And then I have to install agents.
Yes.
I'm
So
taking notes, by the way.
okay.
I want to try this out.
Okay. So now what I will do is, this was the Tokyo region where I hadn't set up network flow monitor. This is the experience you will have. So let's say if I go to let's say Northern California. And so here, since I've already been through the process, you will see something else, right? So what you'll see here is, you'll bypass all those initial things, and you'll come the to this piece where the organizations are all set up, and then you essentially, we have to go through three steps, right? The first is, um, we have to initialize network flow monitor, and I'll explain what that actually means. Step two is, then you actually deploy the agents. And third is, the agent starts sending a bunch of data, and then now you can go and create monitors to figure out, hey, this is what I want to see, this is something I care, this is not something I care. And then what kind of metrics you get, and all of that good stuff, you can see once you go through these initial two steps, right?
Awesome. So Network Flow Monitor is a regional service, though,
That
right?
is correct. Yes.
Perfect. Okay.
Yes. Okay. So the first thing is initialize network flow monitor, and then we come here and say manage settings. And so this is where, you can select the different accounts, and all of that has already been set up. Now what this does is essentially, um, it creates service linked roles for network flow monitor and applies it to the accounts that are in scope, right? So if you look at the single account case, as soon as you add a single account, which is here, right, then that account comes into scope of network flow monitor. And what happens behind the scenes is that network flow monitor goes and takes a snapshot of that particular account. And this
Mm,
is important because, remember, I mentioned how we need to create that path. The only way we can create that path is to first go discover all the different constructs or resources that are in this particular account. And that is what I mean by taking a snapshot. So we take a snapshot. If it is multi-account, if you say 100 accounts, we take a snapshot of all those 100 accounts, and we need permission from you to do that. And that is what this initialization means, because then you're saying, I trust network flow monitor to go and take a snapshot of my account by subscribing to the service linked roles, right? So that is what is
mhm.
happening when you initialize the network flow monitor.
Got it. So here's where we create that topology that of the account. Okay, perfect. Is there a way for customers or users to see that topology? Do we expose it somewhere, or it's
We do.
just okay?
We
That's
do. We when we go to the monitor, and when we are visualizing
awesome.
the monitor or looking at the monitor, then we actually show the topology over there.
Awesome. We'll get to that, I guess. And
Yes.
second question, actually. First, I see more folks joining. Hi, everyone. Thank you for joining us. We're halfway through our demo for Network Flow Monitor. Here's where we get to the good part. So, if you folks have questions, please drop them in the chat. Let us know if you're following along. I would love to follow along, although I have to ask questions here to Vishwas. So I would love to just listen and do all the things in the console. But I'm probably going to watch the recording right after this and set everything up. Um,
Also,
this
to add to, yeah, go ahead, Alex. Sorry.
this doesn't have this wasn't yet the good part. It's just the starting point. So we're gonna get to the good part and see the very cool things you can do with Metric Flow Monitor. Um, Go for it, Vishwas.
What I wanted to add to what you said is, we also have pretty comprehensive documentation, and that actually takes you through step by step through all these different stages. So you don't have to set it up right now, because it still takes like 5 to 10 minutes to set it up and stuff. So
Mhm.
you're welcome to just follow through with me. But then the documentation is pretty good for you to go do it on your own. So
Yep, and we have here. Thank you, Jeff. for posting our links here. Um, we have the links to the documentation. You can always watch the recording. It's going to be posted on the routingloop.net and on YouTube. If you folks are not following us on YouTube yet, please do go follow our channel. And yes, let's continue. So we have initialized the network flow monitor. Network flow monitor did the snapshot of that account that we'd selected, and now we have to install agents.
Yes. So now we go to the installation of the agents method, and so here we offer multiple options for customers, right? Because we understand customers have, we want to meet where they are, and they may have different processes to insert any kind of software to workload or automation and all of that cool stuff. So you can install an agent using the AWS CDK. We provide the code here that you can use. The other one, which is more visual and more straightforward, is the systems manager, which I'm going to walk through. And then, of course, using the CLI from a CLI perspective, you can go to systems manager and install it. And then we can also do using the console. And this is the method I'm going to walk you through. So, as I
Awesome.
said earlier, we support network flow monitor agents on EC2 instances and EKS nodes. On EC2 instances, you can use any of these methods: SSM, CDK, CLI, all of the good stuff. For EKS nodes, we support add-ons. So when you're creating a cluster, you can deploy the add-on, and we can go take a look at that as well. On top of it, we provide a RPM repository for Amazon Linux 2023. You can go to the Amazon Linux CLI and then run a command to pull the repository and install it. That's another option. The last one is, as Alex was mentioning earlier, we open source the agent. So if you want to go look at the code, see what it is doing, maybe have security take a look at it because you're installing it on workloads, and let's say if you want to create your own RPM based off of that for whatever reason, for a distribution we may not support. So today we support Ubuntu, Debian, SUSE, AL 2023, Red Hat, all these popular distributions, and the latest versions as well. But in case there is a need for you to go build your own, you can also do that. So
Nice.
plenty of options for customers to deploy the agent. Again, for us, the key here is the agents give us only the first piece of information, which is the end-to-end metrics. All the magic happens based on those metrics, which we then bring together and provide that health indicator. Okay.
Awesome. One quick note first. I think I've seen, and please correct me if I'm wrong, but I can actually also deploy it as part of EKS deployment process, right? I
Yes.
have a tick box there that says deploy also network flow monitor agent as an add-on, and it just goes and deploys it on the worker nodes, right?
Yes, it does.
That's amazing. And we have a question here that I do really want to answer. So Pete is asking, what about load balancer, transit gateways, VPNs, etc.? This is for EC2 and EKS. Correct. This is for EC2 and EKS because these are the actual workload infrastructure or compute that you have in your deployment or in your infrastructure. These other things that you've mentioned, load balancers, transit gateways, cloud WANs, VPNs, etc. These are gateways, right? We have a history of naming all things gateways. You will see, and Vishwas was talking about this. We do that correlation with your topology, right? So your traffic from, I don't know, let's say a client which is on EC2 to a service which runs on a pod in an EKS cluster, goes through an ingress controller, load balancer, network load balancer, application load balancer. We map all this path as part of that topology information. So
Yep.
all
Just
these
to
components are taken into consideration. Yeah,
Yes,
go
you're
for it.
100% right, Alex. The agents need to be installed only on compute. Whatever passes the traffic, we look at it from a topology perspective. So that's one. And the second is, for all the constructs that you mentioned, Pete, we get the health indicators from those boxes. That's how we correlate if there is any TGW issue that is impacting your workload, the metrics for which we derive from the agents running on compute.
That's
So you don't have
awesome.
to deploy agents on any of the middle boxes. Yeah.
Yes, really, really love it. Also, Interesting, especially on customer trust, running on customers' accounts. Yep, you make the decision to install the agent. The agent collects the data at the kernel level, so it subscribes to the kernel notifications and does export that data to the network flow monitor. So essentially, yes, when you're initializing it, you're giving it access to map your topology in the account, and then you're giving these agents the permissions to export that flow information to the network flow monitor. So totally. It does require the visibility though.
Yes, and this is the same with any, let's say, third-party passive monitoring solutions, which are agent-based. It's on the customer to deploy the agents on workloads that matter to them, right? And so maybe not all the workloads are of interest, and you have very critical workloads that you want to see the network performance. So you pick and choose where you want to deploy the agents.
Excellent. Okay, perfect.
Cool.
Let's see. Installing agents.
Yes. So one of the methods I mentioned earlier was through Systems Manager. So Amazon Linux 2023 or AL2 will already have the System Manager built into it in the ARMY itself. So all this does is we have the agent repositories or the network flow monitor agent as a distributor package in Systems Manager. So if you come here and look at all the different ones, so this is the Amazon CloudWatch network flow monitor agent. This is the package itself. So you can just select it and then you can say install
Vishwas,
on a yeah.
sorry for interrupting. Please do
Oh,
Command Plus a bit because it's a bit small.
is this
Okay, perfect.
okay? Okay, cool. Thanks, Alex. Yep. So you can select the agent, and then you can say, you can pick the instances where you want to deploy it on a schedule or install one time. So let's say you pick install one time, and then what it is doing is essentially as a systems manager already has. The inventory of all the EC2 instances running in your account and all of that good stuff. So you can pick one of the instances, and then you can select this, and then you can say deploy, right, or run. What this does is SSM basically sends a message sends the package to that EC2 instance, and that is EC2 the SSM agent or the EC2 instance deploys the agent, and so there you go. This is one way to do it using SSM.
Awesome.
Now,
That was so easy.
yes, it's a pretty easy, and then you can also pick things such as, hey, do you want the default, the latest, and so on and so forth. So even that is quite straightforward. Um, uh, and you can also deploy it through tags. So any capability that SSM provides out of the box, we leverage it using this method.
Awesome. Love it.
Now, some customers may not use SSM. Maybe they want to deploy it through the Yum package themselves. All of that is in that particular documentation under the install agent section. Or we kind of document all the different ways of doing it. Now, just by running the command doesn't mean it's going to actually activate. So it's a two-step process. The first is how do you deploy the agent on an EC2 instance, and then the next one would actually be to activate it, right? Which
Mhm.
is then you need to send another command to the um, so Amazon CloudWatch. Actually, let me just do this. Okay, so here's the command to actually activate
Mhm.
the agent. So if you select this, and then you can create a document and what is this? Yeah, you can run this particular command, and then this basically means that it's going to go and activate that agent on the EC2 instance as well. So now once you activate it, it essentially means that the agent is now it's subscribed to the kernel notifications. It is looking at the TCP flows, and then it starts sending metrics to the network flow monitor agent API.
Awesome. And I see this one. It's also supported on Linux, Windows, Mac, all the operating systems.
Yes. Oh no, we support only on the Linux operating system,
Hmm.
Alex. We support it on the AL2, AL 2023, Debian, Ubuntu, SUSE, Red Hat, all those distributions. Windows, we don't have support for it.
Got it. Let us know in the chat, folks, if you want this supported for Windows or Mac instances. Go for it. Let us know.
Okay, so yeah, this is what I was talking about in terms of running a command to activate it. And so the command is actually built into it, but if you look at the documentation, it'll actually say which particular command it's sending, and so on and so forth. So once this happens, you have essentially deployed the agent on the EC2 instances. Now the next step is, so we can go back here, and once you deploy the agents, now you don't have to configure the where it's going to send the data. That's already pre-programmed into the agent.
Very
There's
cool.
a popular network flow monitor ingestion endpoint, and all the agents will basically send the things there. Now there is two more things we can do. One is, if you want, it basically uses the public IP, so it goes through the IGW, goes through internet and stuff, reaches the network flow monitor ingestion API. If you can also do it through a private link, right? If you feel like all this data needs to go internally on the Amazon network, then you can also set up using a private link.
Perfect. Okay, so I can create a private link for CloudWatch. Is it? I don't think it's logs. Is it specific for CloudWatch Network Flow Monitor, a private link endpoint? I should
Yes,
probably check that. Okay,
yes,
perfect.
it is. It's specific to. Actually, let me just bring this up as a. Yeah. So install agents. Yes. So if you come here, it talks about all the different steps. Yes, it's a private link for the network flow monitor
Perfect.
ingestion.
Okay.
Yep.
Awesome. There's a lot of plus ones in the chat. So we have BTEC plus one for Windows, High Herrings plus one for Windows. So you got it, Vishwas. Here's the feedback.
All right.
We
Thank you.
can't talk about roadmap on this show, but we can always take feedback. So you folks are in the right place here.
Okay, so this is what I was talking about in the documentation. So there's all the good stuff that you can follow through on this. Um, Now, what I also, yeah, so here are more details on the using the yum if you want to. Actually, let me just do this. Give me a second, Alex. I remember
Yes,
what you said.
perfect. Thank you. Thank you. I was just about to say that.
I gotcha. I gotcha. Okay, so Linux Army is using a Yum repository 2023, and all the different Debian, Ubuntu. So all the instructions are here to kind of deploy it. It's actually pretty straightforward. Okay,
Perfect.
so now once the agents are deployed, network monitor permissions are set. Agents start sending telemetry back to network flow monitor, right? So this is where we come to the interesting piece, which is now I'm going to switch to. Let me
We
sign in
actually need an
again.
account that has traffic in it, right? So we need to see some flows. So you're going to switch to an account that actually has some flows, right?
Yes, let me switch
Okay.
to one. Let me do this here. Okay.
And a bit of a zoom in, please.
Yes. It's too much. Let's stop it. Okay.
Oh,
So now,
a bit more would be good.
okay,
That's perfect.
what's the fruit for our labor, right? Now we did all of that good stuff. Then what I'm going to do is I'm going to take you through a eat your own dog food kind of a system that we have internally, which is at scale with thousands of agents deployed and looking at very interesting things. So we come to flow monitors, and we have gone through the three steps. And then here's the so let's yeah we finished step one and step two, and now we are looking at the console. So now, as the agents send those metrics for the phi tuple, have something called as workload insights. Think of this as application discovery or workload discovery, right? So the agents
Interesting.
are seeing all these different workloads, and you as a user needs to understand, okay, this is what is actually happening in my network in terms of workloads and experience and all of that. And then you can decide, hey, I don't care about all this other stuff, but this is very critical for me, and I want to monitor this on a day by day or minute by minute basis. So in order to do that kind of a decision, you come to workload insights, and here right at the top we give you different buckets, right? So for example, flows that are within an AZ, meaning both the local resource and the remote resource, they're talking to each other and they both are in the same AZ. And then between AZs, different, so a local is on one AZ and a remote is on a different AZ, but they're in the same region between VPCs, right? And right now we support only this within the same region. So here there are two VPCs, but they're in the same region. Then there are flows that are going to S3, DynamoDB, and then any other flow that we are not classifying today. Like for example, flows going to the internet, flows going to on-premises, and flows going to a different region, for example. They are all under the unclassified bucket. And how can we do this bucketization? Because we have that snapshot. Of the snapshot of the account, we kind of know where the remote resources are, and so we can group these flows into these buckets. So yeah, go ahead, Alex.
And this is an aggregate of like, let's say I have 100 EC2 instances and EKS clusters and all that stuff. This is an aggregate of all that data being transferred, right?
That is correct. Yes, at a subnet level,
Okay,
right?
perfect. But I
So
haven't selected yet the subnets, so it takes
correct.
it by default across all the subnets that I
By
have.
default, yes. So
Okay,
if you look
perfect.
here, for example, so let's look at within an AZ. So if you look at within an AZ, right now we have these three top contributors. So there are these
Oh,
three local subnets talking to three different other subnets, but they're all in the same VPC in the same region, but different AZs. So what this
mhm,
actually means is that the look. Let's say you have 10 agents deployed in a certain AZ. Now we are aggregating the flows from those 10 agents, and they could be split across three different subnets, right? So you
mhm,
get a line by line breakdown of the aggregated metrics per subnet, and you
mhm.
have the top
Very cool.
contributors, right? And
Okay.
so and what you see also here is data transferred to basically your top talkers in terms of who's talking the most. Then you have retransmission timeouts, right? So this is essentially, since we are talking about TCP, retransmission timeouts are a proxy for packet loss,
Mhm.
right? The way TCP protocol works, if there is a multiple retransmissions that happen because of a network issue, and then eventually the timeout happens, then it counts as a retransmission timeout, and this is how we get to know from the agent saying, hey, by the way, this 5 tuple that we had timed out, and this is when the timeout event happened, and all those other details we get from there.
Got it. We have a quick question here,
Yes.
actually. So for traffic to S3, is it traffic that goes through the internet gateway, or does it know if it's going through gateway endpoint or interface endpoint?
Today it is through internet, right?
Mhm.
But we are also working on supporting the other ways of reaching S3. But today we what
Cool.
we support is only the internet side.
Internet, IE, as in, does it work for both
IGW,
public and private subnets? And like essentially all traffic that's going through IGW, right?
correct. That's right.
Okay. Okay.
Yes,
And the traffic that would go today through to S3 through the gateway endpoint or interface endpoint would be marked as unclassified, right?
absolutely right. Yes,
Okay. And here's where, for example, you can correlate that with flow logs information, because you can get flow logs information on your VPC, and you can see what is that traffic that's going through the gateway endpoint or the interface endpoint from flow logs. So you can correlate these two together. It's pretty cool.
cool. And then we also look at retransmissions. So these are the three things that you can look at, and then based on, let's say, hey, I'm really interested to know this particular traffic aggregation, because I'm seeing
Mhm.
a bunch of retransmission timeouts for this particular subnet traffic, and then you can say I want to go and create a monitor, right? So what happens here is essentially see how the local resource and the remote resource automatically got selected, right? So we selected a subnet ending in 664 as a local resource, and then a remote resource is also on the same subnet. Is it hmm, interesting?
Yep.
Okay. um, Yeah, okay. I need to look at that. But essentially, you can select on the local side your subnets, and you can select on the remote side, whether you want it to go to everywhere. In the sense, this traffic can go to, pretty much in the same AZ, different AZ, S3, it doesn't matter. You can pick that, or you can pick the different AZs, You can select different AZs, or you can select the different services, or you can select VPCs, and so on and so forth. So you can pick and choose your local resource and remote resource that you're interested in, and then you can go create a monitor.
And the least or the smallest aggregator is the subnet, right? You can go more specific than a subnet.
That is correct. Yes. Yes. So you can go higher up though. So let's say you're interested in all the flows in a particular AZ, going to, let's say, certain service like S3, right? You can create, so depending on what you are looking at, whether it is to a certain service based on a VPC, AZ, whatever, you can slice and dice the creation of the monitor,
Got it. Pretty cool. Okay.
right?
Awesome.
And then once you create that monitor, it takes a few minutes for the monitor to start, aggregating the data in the precise dimensions that you want, and then start vending metrics. Now, none of the metrics that you see here is vended to CloudWatch today, right? The reason is because this is just an application discovery method for us. And once you create a monitor, all the metrics that you get from the monitor is vended to CloudWatch. So let's say, let's look at a bunch of monitors that we've already created. And let's look at, let's say everywhere. This is a monitor that we can deep dive into. And so here, if you look at the monitor details, it is the local side. What we are saying is that this is, the two subnets that we are interested as the source side, and remote is pretty much everywhere, right? And so given that definition of the monitor, what we essentially see here is, for all the flows that fit that filter, we do the data transfer, retransmission timeouts, retransmissions, and the round trip time as well. So and if, because it's in the same AZ, the particular monitor we created, we're looking at, like, we provide microsecond granularity for the round trip time, right?
Awesome. Love
So
it.
this is, and if you go back to the initial discussion we were having, this is essentially the metrics on day-to-day basis, every 30 seconds, and then we compute the baseline based on these metrics for each of the different dimensions. And so once and we can go back in time and look at an instance where that baseline was cut, and so on and so forth. But based on this baseline, we then detect anomalies, and
Mhm.
then anomalies basically trigger a health check.
That's awesome. Okay, love it. There's a very, very good question in the chat here from DP. What about cross account access using, let's say, VPC Lattice as a transport?
Okay, we don't support it today. What we support cross account, but the VPC constructs that we support today are NLB, NAT gateway, IGW, and transit gateway. Those are
Got
the
it.
four resources we support in the path, which we are always looking to expand that to as many more constructs as possible in the future.
So +1 to CloudWatch, +1 to VPC Lattice, +1 to Private Link. So these are three things. Let us know in the chat. +1 to which one of these, or to all
Yes.
of these. Share your feedback. And I also have one more question. Actually, I promised I'm going to ask you, so I'm going to ask you: does this support IPv6? Does this traffic take into account IPv6 traffic?
No, not today. We do. We No, not today. That is something we are looking at. Yes.
Okay, perfect. So +1 to all from BTech here, +1 to IPv6 as well, please. I will follow up with you on that.
Yes, absolutely. Yep.
Cool.
Okay, so these are the metrics that we get from the agents, and that is, as we discussed, baseline, anomaly, and all of that stuff. This is the interesting stuff, right? Which is the network health indicator. This essentially is the result of mapping these flows to the underlying, like, if the path is going through a TGW or an NLB, or all the other constructs that we just discussed, then you essentially get a network health indicator value. If it is 1, then it's a degraded state, and then if it is 0, that means there are no issues. So now if you see during this, and so we can go back in time and take a look at that particular case where we did see a network health indicator, and that's useful. But essentially, this is something that customers ask for, which is, hey, I'd set up all of these workloads, AWS is giving me all of this good stuff, but then tell me when there are AWS network issues that are impacting my workloads, not some synthetic traffic or anything, but my workloads. In this case, it's a healthy state, so you can also see here it's healthy. Now, If you want to go dig further, and this is where Alex, your earlier question was about the actual topology and the flow information itself, right? So if you come to Historical Explorer and you look at the last 1 hour worth of data, then here are all the different flows or the four tuples. We leave out the ephemeral port, but we look at the well-known port. And so these are all the different flows, individual flows that had some kind of an impairment. So if you look at retransmissions, you can see here that all these different flows had some positive retransmission metric. And if you come below, there are retransmission timeouts, which is basically a proxy for packet losses. And so yeah, and then you can have these packet loss for a variety of reasons. Now, not necessarily because of a networking issue, but you can see all of those here, and so you can dig deep to it. So for example, there was a question around Amazon S3, and so if you look here, so let's say, let's pick something. There's a lot of IPv6 stuff here, Alex, but this is
Yeah,
more
I see that.
on the
Those are
control plane
the
side. Yeah.
mapped V6 before
Yep.
I just used to V6.
Yep. um yeah, so I'm picking something that is interesting, probably goes through some kind of TGW. Let's see.
Before while you're searching for that, I see the topology there. It's pretty cool.
Yes.
Love it.
Yes. So the topology is essentially for the flow that you selected. And I was trying to pick a flow that gives something more, rather than just EC2 to EC2. But yes, you're right. So this is the topology where if there's a TGW NLB in the path or an IGW going through S3, then you kind of have those middle all those boxes here as part of the topology,
Cool. Okay, perfect.
right?
We are 4 minutes
Okay.
away
Here is an example.
from finalizing. Oh, perfect.
Sorry,
Okay.
yeah, this was the one I was looking for. Like, so here's the for the question. EC2 talking to S3. We have visibility all the way to the internet gateway. And so anything, if there's any network issue on this path, then that will flag the network health indicator. In this case, we everything is healthy, so you probably don't see anything. but but this was an example where I wanted to kind of find that. Okay, so
Awesome.
now, before we run out of time, let's go back in time, right? So I think let because we want to show the customers. Let's go back 12 months, let's say. Da-da-da. Okay, so let's go back in time, and then yeah, so we put the system in place sometime in early January. But then there
Mhm.
have been multiple issues here, you can see. So let's where the network health indicator actually shows degraded, right? So
Mhm.
otherwise it's been mostly healthy. So let's go and pick this particular time frame, and then see here, for example, between January 22nd and 23rd, there was an AWS network event that had the degraded network performance that impacted this particular workload that we have set up the monitor for, right? And so if you go down, you will see anomalies. I think this was probably the anomaly that you can see here. For
Mhm.
example, this was the baseline, and then we use seasonality and a bunch of other things to calculate the anomaly, for example. So it's not like just because there is a spike there's an anomaly, but in this case this was an anomaly, and that
Mhm.
triggered a health check. And when that health check happened, we kind of showed that AWS network health indicator as unhealthy. Now, the cool part is, of course, if you come to the all metrics piece on CloudWatch itself, and if you come to um, network flow monitor, let's see, if you come to network flow monitor. So all those metrics that we discussed, we went 5 metrics per monitor, and all of those metrics are available here. And so you can essentially, so data transfer 1, 2, 3, 4,
Oh,
5,
that's awesome.
right? So you can then create alerts on top of this. You can do other things on
That's
it.
so
You can
cool.
trigger Lambda. You can do a bunch of things on top of this, right? So this is some of the remediation mitigation actions that I was talking about. For example, let's say you pick retransmission timeouts as one of them, right? You can then
Mhm.
select it. You can then go create uh, let's say create an alarm.
Mm.
You can define thresholds. You can do anomaly detection and so on and so forth. So let's pick default, and then range the number, and then you can trigger a bunch of actions on top of it.
That's really
So
cool.
here,
we are running out of time. So this was really, really awesome, Vishwas. Thank you so much. I'll personally go check it out and install it in my own account after the session. I hope we've answered a lot of your questions, folks. I hope you are going to also try it out. It's really cool. Please let us know your feedback. Reach out to us on LinkedIn, on the routing loop for the feedback form. Let us know what you would like to see more. We are going to meet again next week with another session. I think on network monitoring, but follow the routing loop upcoming episodes and you'll find more details there. Until next week, thank you so much, folks. Have an awesome rest of the week, rest of the day, and an awesome long weekend for those of you celebrating Labor Day in US. Thank you.
Thank you.